Hello everyone! Today I want to tell about this refractory and also a conflict-making metal, tantalum. In the periodic table of chemical elements, tantalum is located in the fifth group, among the so-called transitional refractory metals. Due to its rarity and difficulty in obtaining, tantalum was named after the Greek king Tantalus. According to the legend, he offended Zeus and the other gods, for which he was cast out of heaven for an eternal torment. Like the ancient Greek king, many scientists and researchers have suffered and endured trying to obtain this element in its pure form. Externally, tantalum looks like a grey shiny metal, and by the way quite heavy. In its density it comes next after the gold. If you take the current market price, 1 kilogram of tantalum costs around $150, therefore this metal is quite expensive. Tantalum is very ductile. It's very easy to make a wire or foil from it. This metal is extracted from the mineral coltan, the deposits of which are located in Brazil, but especially rich deposits of tantalum ores are found in Central Africa. Recently, tantalum is referred to a conflict-making metal, because a lot of African countries are fighting to get their hands on it. For example, in Congo and Rwanda, there are military conflicts associated with the smuggling of tantalum ore. From about the last decade, about 9 African countries and 20 different military groups were involved in the tantalum wars. However, let's go back to the chemical properties of the tantalum metal. From the chemical point of view, this metal is extremely stable. It's not soluble in dilute acids, even in the hydrochloric acid, due to a very robust oxide film covering the metal. One of the very few caustic environments that can dissolve tantalum is a mixture of hydrofluoric acid and nitric acid, in which from the tantalum a complex compound forms that is soluble in water. In the form of a powder, tantalum burns quite well in air, forming the tantalum oxide. In spite of all its chemical stability, this metal also reacts well with molten alkalis, forming tantalates. For example, if you pour a bit of dry sodium hydroxide on the tantalum foil and then melt it, such an aggressive environment can easily dissolve the tantalum and burn a hole in the tantalum foil. Through the sprechomatite, you cannot conduct any other special chemical experiments with tantalum due to its inertness. The only thing we can do is heat the tantalum rod and see how fast will it oxidize in the hot flame of a gas burner. After such an abuse, tantalum rod gets covered with a white and inert substance, tantalum oxide, from reacting with oxygen in air. This material is also used in creating glass that absorbs gamma rays. Because of its plasticity and chemical stability, in the olden days tantalum was used for making filaments for light bulbs, but later, with the rise of the price for this metal, tantalum was replaced with a much cheaper tungsten. The internal resistivity of tantalum is comparable to the one of steel, hence this element can be used to create heating elements instead of using nichrome, especially in places where you need a very high temperature, as tantalum melts at more or less about 3000 degrees Celsius. So, for example, it's possible to heat the tantalum wire, and it will not oxidize as much. At the moment, one of the most important applications of tantalum is in manufacturing the most efficient tantalum capacitors in electronics. In the capacitors, like anode, a very fine tantalum powder is used, which is pressed around the tantalum wire and disintegrated to the form of a sponge. Then such sponge is anodized, i.e. covered with a layer of tantalum pentoxide that acts as a dielectric layer. Next, the anodized tantalum sponge is covered with a layer of the cathode of manganese dioxide. Then, on top, a layer of graphite and a layer of silver is added, and now the capacitor is ready. The advantage of these capacitors is that they can be made to be extremely small due to the very thin dielectric film. These kind of capacitors can be put into any computer, smartphone or a tablet. So say thanks to tantalum for the smartphones. Recently jewelers are trying to use tantalum in the jewelry, as this metal is quite dense and is completely non-toxic to humans. Now even the Chinese sell tantalum rings. Would you give your girlfriend a tantalum decoration? In my opinion, it will be quite original. However, tantalum by itself is grey and doesn't shine as beautifully as gold. That I decided to fix with the help of electrochemistry. For this, I took a piece of tantalum foil and placed it into the solution of a table salt, and then connected it to the anode of the power source that will pick up electrons from the metal. As cathode, you can take the same plate of a tantalum foil or any other piece of metal. Next, and the most easy part, you simply need to input the necessary voltage, and voila, grey tantalum becomes golden. The higher the voltage, the more interesting will be colors of the anodized tantalum. In this photo you can see what color will the anodized tantalum take, depending on the voltage. That is, the higher the voltage, the more blue will be the color. So you may ask, what happens in this miracle system? It's actually quite simple. Depending on the applied voltage on the tantalum foil, which is the anode, a layer of tantalum oxide is formed. The higher the voltage, the thicker will be the film of oxide on the metal surface. The thickness of the film will change the color reflected from it, in consequence of the effect of superimposing waves on the reflected light and the light transmitted through the film layer. Through the gradual removal of the metal from the solution, you can get some beautiful effects, like a rainbow coloring or a color gradient. Sometimes you can get whole masterpieces with a simple power supply and haste. So in theory, you can attach a new color to the tantalum wedding ring every year of life being together, because the oxide film is almost unerasable, and the new ones will be brighter and bluer. I feel that you can attach a whole philosophy theory to this effect. After playing with this system, I got some interesting samples that you are now seeing on the screen. In addition to these aesthetic purposes, now pure tantalum is also used in the creation of superalloys, for example, in the alloy of titanium and the alloy of hafnium. Additionally, due to the excellent biocompatibility of tantalum, it is used as a bioprosthesis in surgeries. Even in the year 2006, Kazakhstan issued commemorative coins made of silver and tantalum. For the provided tantalum for the experiments, I'll thank the company Stanford Advanced Materials. I put a link to their site in the video description. Now you know a little bit more about one of the other metals. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description. Please like this video and subscribe to my channel to see many more new and interesting